Secant, we have studied those words before, but they were lines on a slate, and it was two-dimensional. So now we're talking about space and sphere. So it's going to be similar to the words that we learned before, but we're looking at tangent planes and secant planes versus tangent lines and secant lines. And then we have some theorems about spheres that we're going to look at. And then we have a formula to calculate the arc length on a sphere. That are a given distance from a given point, the center. So that would be right here, the center O. So the sphere would be all the points that are all the same distance from the center. It's once, and we can say that line BC is a secant because it goes through twice. And secant lines, and now we're going to look at what a secant plane is. A secant plane is a plane that intersects a sphere in more than one point. So the plane is intersecting that sphere. It's going through that sphere. So think of it like a basketball and cutting through that basketball. So that cut would be the plane. A tangent intersects the plane at exactly one point, and we call that point the point of tangency. So again, think of a basketball and think of something flat right on top of that basketball, and that point where that item is touching the basketball, that is the point of tangency because it's only intersecting the sphere exactly in one point. Intersection of a sphere and a secant plane, so remember a secant plane is one that goes completely through the sphere, is a circle. So all the intersections of the secant planes are circles. So if you have plane N, and plane N is secant to sphere S, here, we would say that when it intersects, it makes this circle here, circle D. A great circle is the intersection of the sphere and a secant plane that contains the center of the sphere. So the great circle is the largest circle that can be made from a secant plane in a sphere. If we have 2 points on a sphere that are not on the same diameter, they lie on exactly one great circle of the sphere. So here are 2 points. They're both on circle O. Two great circles of the sphere intersect at 2 points that are endpoints of a diameter of the sphere. So again, because those great circles contain the center, those points right here, they all have to be on the diameter of the sphere. All great circles of a sphere are congruent. They're all the same size. Again, that's the biggest circle that you can get is the great circle. So that great circle is the same as that great circle, which is the same as that great circle. So again, they all contain the center or the diameter of that sphere. And if you notice, there are tons of great circles. A secant plane of a sphere is perpendicular, which means it intersects at a 90-degree angle to the line containing the center of the circle of intersection and the center of the sphere. The next theorem says that a plane is tangent to a sphere if and only it is perpendicular to the radius at the point of tangency. So that means the point of tangency and the radius, they're going to be perpendicular, which means that if you were to connect them, they would connect at a 90-degree angle. To find the distance between A and B, which is an arc right here, first of all, you must find the length of the arc of the great circle that contains A and B. So here's the great circle that contains A and B, arc AB. So the distance between A and B is going to be equal to the measure of the arc AB divided by 360 and then multiplied by 2 pi r. So this is our formula on how to get the distance of an arc on a sphere.